Hi everyone, welcome back to Self Learning. In this video, we were building a smart math chatbot using only Python and Streamlit. No APIs, no model downloads, just core Python libraries like math, sympy, and numpy. We will build it step by step. First, the UI with Streamlit, then basic math, then integration, differentiation, and finally matrix operation. Each steps add a new feature, so don't skip. Let's get started. Before we jump in, let's install the required libraries. You only need four main packages: Streamlit for UI, sympy for symbolic math like integration and differentiation, numpy for matrix operation, and Python's built-in math module which we don't need to install. Just open your terminal and run pip install Streamlit, sympy, and numpy. Once it's done, let's move into the code. Import Streamlit as ST. We will use Streamlit to build our chatbot interface. This handles our input and output on the web app. Set the browser tab title to Math Chatbot. It's useful for customizing the tab name. This adds a big page title at the top of the app, Smart Math Chatbot. It tells user what the app is about. Here we initialize the chat history. st.session_state. Let us store data between interactions so we don't lose message after the user types something. This line creates a chat input box at the bottom. The prompt says, "Ask me anything math related," and the user types their question here. If the user submits a message, we save it to the chat history. Then we stimulate a bot replay. For now, it's just a placeholder so we can test the chat UI. Finally, this loop displays each message using st.chat_message. It checks whether the message is from the user or the bot and shows it with proper formatting. Now, let's run the app using Streamlit. In the terminal, I type Streamlit run app.py. This launches a local server and opens the app in the browser. Here's our chatbot interface. At the top, we have the title Smart Math Chatbot. This comes from the st.title function line in our code. At the bottom, you can see the chat input box that's created using st.chat_input function. It lets users type questions or messages. Now I will type a simple message, "Hello chatbot." It shows my message inside the chat and the bot replies with a placeholder response. This default message is hard-coded for now. We will replace it with real logic shortly. So that's our basic UI setup. The app can accept user input, display chat history, and create responses. This sets the foundation for the logic we will build next. In the next step, we will make the bot solve real math like 2 plus 2, square roots, and more. Once you are done testing, you can stop the app by going back to the terminal. Just press Ctrl+C on your keyboard. This will safely shut down the Streamlit server. Now, let's make our chatbot solve simple math problems. This includes addition, subtraction, multiplication, division, powers, and more. First, we import the math and RE modules. Math gives us access to functions like square root and log. RE stands for regular expressions. We use it to clean the user input. Next, we defined a dictionary called replacement. This maps natural language like plus or divided by to actual symbols like plus or by. Then we write a function called clean_input. It removes unnecessary words like what is or calculate and replace phrases like square root of 9 with math.square root function of 9. Next, we create a save_evolve function. It uses Python's evolve function to evaluate the cleaned up math expressions. We limit access to built-ins and only allow the math module for safety. Finally, in our main chat logic, we remove the placeholder response and instead clean the user input and evaluate. The result is shown as the chatbot's replay. Alright, let's rerun our app with the command Streamlit run app.py. This will open the chatbot in our browser. The interface is simple. We have a title at the top and a chat input at the bottom, just like a messaging app. Now, let's test a basic math question. I will type what is 2 plus 3. Our code will clean the input, replace the word plus with the plus symbol, and then safely evaluate 2 plus 3. The bot replies with 5, which is correct, and looks, Streamlit launches cute balloons when the result is successful. Let's try another one. Evaluate 6 multiplied by 7. Just like before, the word multiplied by is replaced with asterisk, and 6 multiplied by 7 is evaluated as 42. And again, we see balloons. The balloon effect only triggers when there is no error in the result. This gives users a fun visual confirmation when the math query is valid. That's it. We now have a working chatbot that understands basic math in natural language. Welcome to step 3. And in this step, we were upgrading our chatbot to perform symbolic integration. This means solving calculus problems like integrate x squared dx. We will use the sympy library, which is a symbolic mathematics library in Python, perfect for calculus, algebra, and expression simplification. Import the required pieces from sympy. From sympy, import symbols, simplify, integrate, latex. X equal to symbols of x. Symbols of x tells sympy to treat x as a symbolic variable, not a number. It's like telling Python, hey, from now on, x is a math variable. Simplify is a safe way to convert a string into a symbolic math expression. For example, x power 2 turns into a real sympy expression x squared. Integrate is the actual function that performs integration. For example, integrate x squared becomes x cubed by 3. Latex function is optional but very helpful. It converts the symbolic result into latex format, so we can show clean, pretty math inside the app. Now we define our integration logic in a reusable function. We pass a string like x power 3 into this function. Simplify converts that to symbolic form. Integrate function performs that integration with respect to x. If anything fails, maybe the user types gibberish, we show a clean error message. Now, let's plug this function into our main chatbot logic. Inside the input handling block, we add a check. This line detects whether the user is trying to integrate something. For example, if the user type integrate x power 3, we remove the integrate and keep only the expression x power 3. Then we pass it to our function. After we get the result from the integration function, we check if the result is a symbolic object, not just a number. If it is, we convert it to latex format. This makes the final output show up beautifully with proper math symbol. Let's test in our Streamlit app. I will type integrate x power 2. The chatbot replies x cubed by 3, beautifully rendered, math style, exactly what we expect from the calculus engine, and yes, balloon again. With this, you now have a math chatbot that can solve integrals symbolically, show them beautifully, and even animate success with balloons. We now import diff from sympy to handle differentiations. This lets us calculate symbolic derivatives easily. Next, we define a function called handle_differentiation. It takes the expression, converts it to a symbolic form using simplify, and then calculates its derivatives with respect to x using diff. If anything goes wrong, we catch the error and return it. In the main logic section, we check if the user input starts with the word differentiate. If yes, we extract the expression and pass it to our differentiation handler. Just like with integration, if the result is symbolic, we format it using LaTeX for a cleaner display. With this step, our chatbot can now solve differentiation problems. You can try expression like differentiate x squared or differentiate sine of x, and it will give you the correct symbolic result. And remember, just like before, the result will be rendered beautifully in LaTeX if symbolic, and the chat history keeps tracks of everything. We start by importing NumPy as an input. This library is essential for matrix operations like addition, multiplication, and subtraction. Now, we are going to write the most important part of matrix support, a custom function called handle underscore matrix underscore operation. This function is responsible for recognizing, extracting, and solving matrix-related problems from the user inputs. The function takes a single argument, the text entered by the user. This could be something like add two matrices. Our job is to extract the two matrices and understand what operation is being requested. We wrapped everything in a try except block so that if anything goes wrong, like a bad matrix format or math error, we can show a useful message to the user instead of crashing the app. This line defines a regular expression pattern. We were looking for anything that looks like a matrix, meaning a list of lists inside double square brackets. This pattern will help us extract matrices from the plain text input. Here, we apply the pattern to the user text using re.find_all. This gives us a list of all matrices like string. It can find, for example, if the input had two matrices, this line pulls them both out for processing. Now, we check if at least two matrices were found. If not, we send a helpful message asking the user to provide two matrices because operation like addition and multiplication require two. We take the first two matrices from the list and use evolve function to convert the string into actual Python list. Then we wrap them in np.array function to turn them into a proper NumPy matrices. Now comes the logic for operation. If the user says add, we add the two matrices using the plus operator. If the text includes the word subtract, we subtract the second matrix from the first. For multiplication, we check for either the word multiply or dot. We then use NumPy's maximum function. This performs matrix multiplication, not element-wise multiplication. This is important. Matrix multiplication follows a different rule than just multiplying numbers element by element. If the user used words I don't recognize, we return a fallback message that says we don't understand the operation. Finally, if anything at all goes wrong, for example, if the input was malformed or matrix sizes didn't match, the error is caught and returned as a message. This keeps our app stable and user-friendly. Inside the main chatbot logic, we check for the word matrix or double square brackets to decide if the input is a matrix operation. If yes, we pass it to our matrix handler. Now, our chatbot can handle matrix math by input like add two sets of matrix or multiply two matrices. It will calculate and return the result instantly. Alright, the code is ready. Now let's test our chatbot with some example question. I will try different types of math problems and we will see how it responds. First, I will try a simple arithmetic question. 2 plus 3 times 4. It should follow the math rules and give us 14. Let's test a square root. I will type square root of 64. It should return 8. Let's try something interesting. I type log 100 and the chatbot instantly gives me 2.0. Let's check integration now. I will type integrate x power 2. It should return x power 3 by 3. Now, differentiation. Differentiation, since of x, the answer should be cos of x. Let's try matrix addition. It should return the sum of both matrices. One more, let's test matrix multiplication. Since first one is an identity matrix, the result should be the second matrix itself. So far, it's working great. You can test more expressions like trigonometry, powers, logs, even equation if you expand it. And that's it. We have successfully built a smart math chatbot using nothing but Python and Streamlit. We covered step by step a clean Streamlit interface, basic math operation, integration, differentiation, and even matrix operation, all without any external APIs or model downloads, just pure Python logic. You can stop at any step and create your own version or build further from here. If you found this helpful, don't forget to like the video and subscribe Surf Learning for more Python project. Thanks for watching. I will see you in the next one.